guys, this is the second video for chapter E, and then we're going to go ahead and move to chapter 1. So hopefully some of this will be review from other classes, maybe even high school classes, but we're going to start at density. So just remember that density is mass over volume. And normally the units we will use are grams and milliliters. So it's going to have 2 units, which is new. Just remember, grams is not an SI unit. Oops, sorry, dropped my pen. And neither is milliliters, okay? So make sure you don't choose those on that quiz. All right, also, intensive properties. That is a property that is independent of the amount. So it doesn't matter how much there is, the property stays the same. Some common examples of this are like color and temperature and things that you would observe. More qualitative properties. Extensive, on the other hand, does depend on the amount. And to remember these are the MVL men. Okay, it's mass, volume, length, and then moles, energy, number. And when I say number, if it says number of something, number of particles, number of electrons, number of anything, that's what it's talking about for number. All right, so we're going to go ahead and do a problem for density. Just again, remember it's mass over volume. Also, one thing you need to keep in mind that a cc is really a centimeter cubed, or cubic centimeter. That's what cc stands for, but it's also the same as a milliliter in amount. So here we see that centimeter cube is here and so is milliliter. We're just going to pretend they're the same unit because they equal the same unit. Okay, so instead of writing 13.6 grams per centimeter cubed, I'm going to go ahead and write per milliliter. So I've got 13.6 grams per milliliter is equal to M, which I don't know, over 95 milliliters. Okay, we multiply our 13.6 and our 95 to get mass, and I get mass is 1292 grams. However, remember, we need to pay attention to sig figs. This one has 3, 95 has 2. So I'm only keeping 2. That 9's going to round it up. So really, this is 1,300 grams, or 1.3 times 10 to the 3 grams. If y'all need help on sig figs or scientific notation, please let me know. I also want you to know that Mastering Chemistry will take it either way, in standard form or in scientific notation. So you need to be familiar with both. Also, there's a function on the calculator where you can just change it between scientific notation and standard notation. And if you need help changing them, please reach out and I will be happy to help you. All right, so they work through it. Yes, here's our 1.3 times 10 to the 3. We're good. For energy, this is just an introduction to energy. We're not really using energy yet, but we will as we start going through. It's really going to appear again in chapter 2. All right, so just remember that energy is the capacity to do work. And the work is that force applied across a distance. We won't use work in that sense in this class. It's really more a physics standpoint. And that electrostatic force, which is what we use more of, that's that push or pull on objects that have electrical charges. And it's going to depend on if they're positive or negative charge. So one thing to remember, this is the first law of thermodynamics, is that energy is always conserved, which means we cannot create or destroy it. That's normally how it is worded. Energy is not created or destroyed. Okay, also some things to remember. Kinetic energy is energy with movement, and potential energy is either associated with position, so like how high it is, or composition, what it's made up of. That's the kind of potential energy we're going to use, the second one. And then also just remember, while energy can't be created or destroyed, it can transform from one type to another type. And here in this image, it's going from kinetic to potential, really from potential to kinetic and then back to potential. There's lots of other forms of energy, chemical, mechanical, solar, things like that, electrical, lots of different types of energy that they can convert back and forth to. And here we're talking about a system and the surroundings. In chemistry, we focus on the system. Okay. If you are an engineering major, which I haven't come across any of you yet, but it's still before the semester starts, so I'm sure some of you are, they focus on the surroundings, so just make sure you're paying attention to the system for chemistry because that's what we care about. That's what we are studying, their chemical reaction that's happening. We can observe things happening in the surroundings. So something that would be an example of this is like we're doing a reaction in a beaker or a flask and it gets warm. That's not the system getting warm. That's the surroundings getting warm because that's what we get to observe. And then this whole piece is just called the universe. So the system and the surroundings together are everything, which is the universe. Okay, we have endothermic and exothermic. These are really going to come up in chapter 9. So it'll be a little bit before we revisit these. But endothermic means we're putting energy into the system. So it's into the system, which means that the system energy increases, but the surroundings decrease. And then our temperature in the surroundings is going to feel cooler, and that's because it's going into the system. Exothermic, on the other hand, is to the surroundings, so it's leaving the system. And that's when energy in the system is decreasing, but it's increasing in the surroundings. And that is a typo. I will fix that and repost this. And then, so this is increases. And then the temperature of the surroundings is going to go up, so it's going to feel hot. That's what an exothermic process is. All right, so here are some different energy units, and you will need to be able to convert within them and back and forth. But again, you're going to have this because this is an online course. I do need you to note joule because that's the one we are going to focus on. So we used to use calories. Also, we're real familiar with calories because it's on all food products. And that's just the amount of heat needed to raise a temperature of 1 gram of water, 1 degree Celsius. A joule is basically the same thing, but it's a more concrete definition. So this is the SI unit per se is joules. Okay, and then we've got kilocalories, kilojoules. A calorie for food is a kilocalorie. And then also a common energy unit, and if y'all pay your own electric bills, or if you've ever looked at them, that kilowatt hour is always on there. You normally pay by kilowatt hour. So that's super important, especially in these hot summer months for some of us. And we're going to do these conversions with what we call dimensional analysis, which is converting between 2 units and a conversion factor. Remember, that's where it has this equals in it. And just remember, they're either called conversion factors or equivalent statements, and they have unlimited sig figs or infinite. Sorry, that's a mess. Okay, unlimited sig figs. So this is just going through our plan of how we're going to do dimensional analysis, but really it's better to call it unit analysis because it's all about the units and what they're doing. The key is whatever your given unit is, that unit must also be on the bottom of your conversion factor to get the new unit, which is the wanted unit. All right, so here we have centimeters to yards. Because this is an online class, you've got more access to unit conversion things online. I am going to post a unit conversion paper so you have the common ones, because in a normal class setting, you wouldn't have the internet to do it all. Okay, so in a question like this, I would tell you that a yard is equal to 36 inches and that 1 inch is 2.54 centimeters. Okay, so then at that point, you would use those conversion factors. You always start with your given. So I say 1.67 yards, 76 yards. Okay, and the whatever unit is here, it must also go in the bottom of my conversion factor. Once you've determined what goes in the bottom, you look at your conversion factors, and I see that yards is with inches. Okay, whatever number is with the unit, that's what goes with that piece. Once we've used that, we cross out the unit that's on top and bottom. Okay, and then to know if we're done or not, we ask ourselves, is inches what the question asks for? No, it asks for centimeters, so we have to keep going. So inches has to go on bottom, and then my only other choice is centimeters. Again, plug in our numbers. Cross out our units. You do also need to keep in mind that even though this example only has ones on the bottom, that's not how it always is. In fact, it's very rarely that way. Okay, but if the numbers are on top of the conversion factor, you multiply. If they're on bottom, you divide. This one's easier because they're all on top. So I get 160.9344 centimeters. If you chose to write this, I call this calculator vomit because you wrote every single number the calculator wrote down or told you. That's not what we want. We want to pay attention to sig figs. So our given has 3, so we're paying attention to only 3. So our answer is going to be 161 centimeters. Don't forget your units. Units are super, super, super important. All right, so it walks us through all that. And they went through meters and yards, but notice they still got the same answer, 161 centimeters. So that's cool. Now let's go the other way, 288 centimeters to yards. So we're starting with 288 centimeters. We have the same conversion factor, so I'm going to do my 2.54 centimeters is 1 inch. And then 36 inches is 1 yard. You still cross out the units that are the same on top and bottom. Okay, this one is a little different because everything's on bottom. So please always write your given in the calculator first or type it. So I'm going to type 288 divided by 2.54 divided by 36. This means I don't have to use parentheses. If you have a fancy calculator and you want to do it another way, that's fine. But this way will work on any calculator, even a phone calculator. Okay, so if you just push divide by before any number that's on bottom and multiply by on top, you will be good to go. And I get 3.1496 yards. Again, don't write that. We need sig figs. And this one has 3. Again, so 3.15 yards is going to be my answer. Okay, I have tons of practice. If you need extra help, just let me know and I will happily email that over. Okay, so now we're looking at displacement and we're getting units raised to a power. So I've got liters and I've got cubic inches. Okay, so I still start with my given. Well, let's do this. Sorry. Let me write the conversion factors down. A liter is equal to 1,000 milliliters. And remember that 1 milliliter is equal to 1 centimeter cubed, and 1 centimeter is equal to 2.54 centimeters. It's equal to 1 inch. Okay, so we're starting with our 5.70 liters. I need liters at the bottom. My only one with liters is milliliters, and we fill in our values. Cross out what's the same. Next one, I do not want milliliters, I want inches cubed. So milliliters goes at the bottom. centimeters cubed goes at the top, and it's 1 for both, which is convenient. Cross out the unit that's the same. Next one, centimeters and inches. This one is a little different, and it's because it's only a normal unit instead of a cubed unit. So I'm going to go ahead and fill this in with my numbers, but because I need it to be a cubed unit, I'm going to cube that whole piece, which really means that it's 1 cubed, inches cubed, over 2.54 cubed, centimeters cubed. Once we have that, our centimeters cubed can cancel, and we're left with inches cubed. But you have to cube that entire conversion factor. So my calculator, I'm going to do 5.7 times 1,000, and then I'm going to divide that by 2.54 cubed, and I get 348 for sig figs, and it's going to be inches cubed. Okay, you have to make sure you cube this value. This is only if you have units raised to a power. And notice here, I didn't do any cubing. That's because this unit was already raised to a power. It's only for conversion factors that don't have a power, but they need to have one later on. Okay, we'll do one more with yards. Again, remember there's 36 inches in a yard and 2.54 centimeters in an inch. All right, so I have 2.11 yards cubed. Now, sometimes I have students try to cube the given. The given has already been cubed. You only cube it when there's no cubed unit, but I need one. So here I've got yards and inches. This is where I need to cube everything because it wasn't already cubed here. Then we cancel. Oop. Same thing on the next one. I've got inches and centimeters. I have to cube everything to get my inches to cancel. So in my calculator this time, it'll be 2.11 times 36 cubed times 2.54 cubed. And this number is huge. 1,613,210.75. Okay, but I'm only keeping 3 sig figs. So I'm going to do 1.61 times 10 to the, we're going to move our decimal, 1, 2, 3, 4, 5, 6. And that'll be centimeters cubed. Okay, you don't have to put that in scientific notation, but just because it's such a large number, it's easier to read that way. Alrighty. I believe this is our last one. It may not be, but I'm pretty sure it is. So here, we've got more numbers than normal. Okay, we've got this grams per centimeter cubed, which is a density. I've got this volume. I've got this number, but notice there's no unit, so that's just extra information. And it wants kilograms. Okay, so this doesn't matter because it's not a number, it's just the type of jet. Okay, so with these two givens, I need to choose which one I start with. And you always start with the one with 1 unit. So I'm going to start with 173,231 liters. That means liters has to go on bottom and milliliters will go on top. Okay, and remember there's 1 milliliter in 1 centimeter cubed. And then here I've got 0.768 grams in 1 centimeter cubed. This is another thing. Just remember that if it has a slash, that means per, and that's always going to have 1 with whatever unit's on bottom. Okay, also there are 1,000 grams in 1 kilogram. So our grams cancel. So we do our calculation. I get 133,041. I'm keeping 3 sig figs, so I'm going to say 133,000 kilograms, or 1.33 times 10 to the 5 kilograms. Just make sure you pick one and stick with it. Okay, so it's going to go through the whole process. There we are, same thing. If you need more practice, I have plenty. Just reach out. Okay, that's it. So that is it for chapter E. Next time we're going to start chapter 1. Y'all have a good day.